August 28, 1940, the impossible contract. Detroit, Michigan, Chrysler Corporation headquarters. K.T. Keller, Chrysler's president, sat across from U.S. Army ordnance officials who had just presented an extraordinary proposal. The Army wanted Chrysler to build 1,000 M3 medium tanks. The contract was worth $27 million. There were three problems. First, Chrysler had never built a tank. They built cars, sedans, coupes, and trucks, not armored fighting vehicles mounting 75mm guns and 37mm cannon. Second, the M3 tank design wasn't finalized. Army engineers were still modifying specifications. Chrysler would have to build something whose final form remained uncertain. Third, the Army needed the tanks quickly, not in 3 years, within months, faster than seemed possible using traditional military manufacturing methods. Keller's response became legendary. Looking at blueprints and specifications for the M3, he asked simply, "Where can I see one?" The Army officials exchanged glances. There was no M3 to see. The tank existed only as engineering drawings and a wooden mock-up at Aberdeen Proving Ground. Keller studied the plans with the practiced eye of an automotive executive who had spent decades translating engineering concepts into mass-produced reality. He saw not a military weapon, but a mechanical assembly problem. Engines? Chrysler built thousands daily. Transmissions? Same. Armor plates? Just heavy steel that needed cutting, forming, and welding, processes automotive factories performed constantly. Keller said, "We can build these, but we'll need a new factory, a purpose-built tank arsenal using automotive assembly line techniques." The Army agreed. Construction would begin immediately. Skeptics, and there were many, dismissed Chrysler's entry into tank manufacturing as typical American industrial overconfidence. German military intelligence, monitoring American rearmament through diplomatic and espionage channels, noted the tank contract with bemused contempt. Automobile manufacturers building tanks? The very idea suggested Americans didn't understand the complexity of armored warfare. Tanks required precision engineering, specialized metallurgy, and manufacturing expertise developed over years. You couldn't simply convert a car factory to tank production. German generals laughed at the car makers pretending to be armorers. They stopped laughing in 1943, when Detroit Tank Arsenal was producing more tanks monthly than Germany's entire tank industry combined. But by then, the production race was already over. America had won through industrial capacity that Germany never comprehended until far too late.
The site: 113 acres of farmland in Warren, Michigan, technically a Detroit suburb, but at the time mostly rural. Farmers' fields, a few scattered houses, and muddy dirt roads. Within 7 months, this farmland would host the most advanced tank production facility in the world. Architect Albert Kahn, who had designed most of Ford's factories and was America's premier industrial architect, created plans for a structure purpose-built for tank assembly. The main building would measure 1,650 feet long by 420 feet wide, 5 city blocks deep and 2 blocks wide. Total floor space? Nearly 1 million square feet under one roof. Construction began September 11, 1940. The site was still being cleared when steel framing started rising in November. By January 1941, the building's shell was complete enough that equipment installation could begin, even while construction crews worked on unfinished sections. The pace was extraordinary. 7 months from bare farmland to operational tank factory. Critics claimed this rushed construction would result in a facility plagued by problems. They predicted equipment failures, structural issues, and production delays from trying to operate in a building that wasn't fully complete. The critics were wrong. Chrysler applied lessons learned from automotive factory construction, modular design, parallel construction paths, equipment pre-positioning, and workforce training beginning before the facility was finished. Innovative design features. 3-foot-thick concrete walls. The building was designed to withstand aerial bombardment, a real concern in 1940-41 when German bombers were devastating British cities, and Pearl Harbor hadn't yet proven America's geographic immunity. Dual-purpose layout. Kahn designed the facility so it could be converted to peacetime production after the war. The building's structure, power systems, and material handling infrastructure would work equally well for tank production or automotive manufacturing. Assembly line organization. 3 massive parallel assembly lines ran the length of the building. Unlike traditional military arsenals that built weapons piece by piece in job shops, Chrysler's design moved tanks through sequential stations where specialized crews performed specific tasks. Integrated tooling. The facility included not just final assembly, but also die shops, heat treating facilities, machine shops, and foundries capable of producing most components in-house. This vertical integration reduced dependence on suppliers and accelerated production. Employee facilities. Chrysler built extensive cafeterias, locker rooms, medical facilities, and training classrooms. They understood that sustaining high production required taking care of workers. The first M3 tank, officially designated M3 General Grant, though Americans usually called it the M3 Lee after Civil War General Robert E. Lee, rolled off the assembly line on April 24, 1941. 8 months after signing the contract, 4 months before the building was fully complete, months before anyone expected production to begin. The delivery ceremony was broadcast nationwide over radio. VIPs and thousands of workers cheered as the tank fired its 75mm and 37mm guns, smashed telephone poles set up for demonstration, and destroyed a mock-up house. The spectacle was pure American industrial theater, demonstrating that the car makers could indeed build tanks, and build them faster than traditional military arsenals ever achieved.
The M3 medium tank was, charitably speaking, a compromise design, something to get into production quickly while better tanks were developed. Specifications: weight, 27 tons. Crew, 6 to 7 men. Armor, 38mm to 51mm. Main gun, 75mm M2/M3 in sponson mount, limited traverse. Secondary, 37mm gun in turret. Machine guns, 430 caliber Brownings. Engine, Wright R975 Whirlwind Radial, 340 HP. Speed, 26 miles per hour. Range, 120 miles. The M3's most obvious flaw was the hull-mounted 75mm gun with extremely limited traverse, only 15 degrees left or right. To aim, the entire tank had to turn. The turret-mounted 37mm was better situated but already obsolete, unable to penetrate German tank armor at combat ranges. The M3 was tall, over 10 feet, presenting a massive target. The riveted construction used overlapping steel plates held together with thousands of rivets, a construction method that would prove catastrophic when hit. Rivets would shear off and ricochet around the interior like bullets, killing crew even when armor wasn't penetrated. But the M3 had one overwhelming advantage. It could be mass-produced quickly using existing technology and automotive manufacturing techniques. Every component was proven. The engine was a reliable aircraft radial already in production. The transmission used automotive principles. The suspension borrowed from farm tractors. Chrysler built the first M3 while still learning tank manufacturing. Workers who had spent careers building cars suddenly found themselves welding armor plate, installing gun mounts, and assembling track links. The learning curve was steep.
Early M3s took weeks to complete as workers figured out processes and engineers debugged assembly procedures. But Chrysler's automotive experience proved invaluable. The company understood how to organize production lines, train workers quickly, maintain quality control, and continuously improve processes. Techniques that built 5,000 cars weekly could build tanks, just slower initially. By late 1941, Detroit Tank Arsenal was producing 20 M3s weekly. By early 1942, output had reached 100 monthly. The facility was hitting its stride. Total M3 production at Detroit Arsenal, 3,352 tanks, 53% of all M3s built across all manufacturers. But even as M3 production ramped up, everyone knew the M3 was interim. A better tank was needed. Aberdeen Proving Ground engineers were already designing it, the M4 Sherman.
The M4 Sherman addressed the M3's most glaring flaws. The 75mm gun moved into a fully rotating turret, eliminating the awkward hull mount. The profile was lower, the design was simplified. Most importantly, it was engineered specifically for mass production by automotive manufacturers. Detroit Tank Arsenal transitioned from M3 to M4 production in January 1942 while maintaining continuous output. No shutdown, no retooling delays. Workers simply started assembling M4 components as M3 production phased out. By March, the facility was building both designs simultaneously on parallel lines. By May, M3 production had ceased entirely, and 3 lines were producing M4s exclusively. Chrysler's unique contribution, the A57 multi-bank engine. The M4 faced an immediate problem, engine shortages. The standard Wright 975 radial was also used in aircraft, and aircraft production had priority. Various manufacturers developed alternative power plants. Chrysler's solution was characteristically audacious and bizarre. The A57 multi-bank engine consisted of 5 6-cylinder automotive engines based on Chrysler's Flathead 6 used in cars, arranged in a star configuration and geared to a single output shaft. 30 cylinders total. The 5 engines fired in coordinated sequence, producing 370 horsepower at 2,400 RPM or 425 HP at 2,850 RPM. The multi-bank was heavy, complex, and difficult to maintain. U.S. Army Ordnance rejected it for American use, but the British, desperate for any engines, accepted M4A4 Shermans powered by multi-banks. Of 7,499 M4A4s built at Detroit Arsenal, 7,167 went to Britain under Lend-Lease, where they were designated Sherman V. British crews initially hated the multi-bank. It was temperamental, prone to overheating, and required extensive maintenance. But after modifications and proper break-in procedures, the engine proved surprisingly reliable. Many British tank commanders came to prefer M4A4s specifically because the multi-bank, once properly maintained, ran smoothly and delivered consistent power. Chrysler also built standard M4A3s powered by Ford's GAA V8, the engine that became standard for U.S. Army Shermans, and M4A2s with twin GM diesel engines, mostly exported to Soviet Union and Britain.
December 1942. Detroit Tank Arsenal hit peak efficiency. In that single month, the facility's 5,400 workers delivered 907 Sherman tanks to the U.S. Army. 907 complete M4 Sherman medium tanks. In 31 days, an average of 29.3 tanks daily. 1 tank every 49 minutes, around the clock. To understand this achievement's magnitude, compare it to German tank production. In December 1942, Germany's entire tank industry, dozens of factories across German-occupied Europe, produced approximately 750 tanks of all types. 1 Chrysler facility outproduced Germany's total output. The December record would never be broken at Detroit Arsenal, though production remained consistently high through 1943 to 44. The 907-tank month demonstrated what systematic application of automotive mass production techniques could achieve when applied to military equipment. How did they do it? Assembly line choreography. 3 parallel assembly lines moved tanks through sequential stations. As soon as one tank advanced to the next station, another began at the previous station. Flow never stopped. The lines operated 24 hours daily in 3 8-hour shifts. Prefabrication. Major components, hulls, turrets, transmissions, final drives, were built in dedicated shops, then fed to final assembly fully complete. Workers didn't build tanks from raw steel, they assembled pre-manufactured modules. Standardized work. Every job was broken into simple, repeatable steps. Workers didn't need to understand the entire tank, just their specific task. New workers could be trained in days rather than months. Quality control. Inspectors checked work at every station. Problems were fixed immediately rather than allowing defects to proceed down the line. The Army rejected fewer than 2% of tanks for quality issues, extraordinary for a facility producing 900+ monthly. Continuous improvement. Engineers constantly refined processes, eliminated bottlenecks, and improved tooling. What took 50 man-hours in January took 45 by March, 40 by June. Cumulative improvements multiplied efficiency. Worker motivation. Chrysler paid competitive wages and emphasized that production directly supported soldiers fighting overseas. Many workers had family in service. Every tank built might save their loved one's life. That motivation maintained focus despite exhausting schedules and repetitive work.
At peak employment, Detroit Tank Arsenal employed over 10,000 workers in 3 shifts operating around the clock. The workforce composition reflected wartime America's social transformation. Women workers. By 1943, approximately 40% of Arsenal workers were women. They operated rivet guns, drove overhead cranes, welded armor plate, and performed every job except the heaviest lifting. Rosie the Riveter built tanks as much as aircraft. The women proved that tank building didn't require male physical strength. It required skill, training, and attention to detail. African Americans. Detroit's Great Migration had brought tens of thousands of black workers from the South. Chrysler hired black workers for tank production in significant numbers, unusual for 1940s American industry. While discrimination persisted and segregation affected social facilities, the production floor was largely integrated out of practical necessity. Tank building required too many workers for racial barriers to limit the available labor pool. Training programs. Chrysler established extensive training facilities teaching tank assembly skills. New workers spent 1 to 2 weeks in classrooms and hands-on training before joining production lines. The training emphasized safety, quality, and efficiency. Graduates understood not just how to perform their jobs, but why each step mattered. Conditions. The work was hard, dangerous, and exhausting. Heavy steel components, welding equipment, industrial machinery, and constant noise created hazardous environments. Industrial accidents occurred regularly despite safety precautions. Workers died, crushed by cranes, burned by welding accidents, or injured by moving equipment. But the pay was excellent by 1940s standards. $1.20 hourly for skilled workers, roughly $45 weekly. More than double what domestic service or retail paid. For many workers, especially women and minorities, tank building offered economic opportunities previously unavailable. The psychological pressure was intense. Production targets had to be met. Quality couldn't slip. Soldiers' lives depended on reliable equipment. Workers carried that burden daily, knowing their rivets and welds would face combat in North Africa, Italy, France, and Germany.
One worker, interviewed years later, recalled, "Every tank that went down the line, we wondered where it would go. What crew would use it? Would they survive? You couldn't think about that constantly or you'd go crazy, but you couldn't forget it either. So you did your job right, every time, because someone's husband, someone's son, would depend on your work."
Detroit Arsenal's production, 25,082 tanks total from 1941 to 1945, represented approximately 28% of America's entire tank output during World War II. But the impact extended beyond simple numbers. Chrysler's success demonstrated that automotive manufacturers could build complex military equipment using mass production techniques. This proof of concept encouraged similar programs across American industry. Fisher Body Division built tanks at Fisher Tank Arsenal. Ford built tanks at Grand Blanc Tank Arsenal. Other automotive companies transitioned to weapons production. The cumulative result? America produced 89,568 tanks during World War II, compared to Germany's approximately 40,700 tanks of all types from 1939 to 1945. American tank production exceeded German output, despite starting later, operating under tighter quality standards, and building more complex vehicles. The disparity stemmed directly from automotive industry participation bringing mass production expertise to military manufacturing. German tank production relied on traditional methods, skilled craftsmen building vehicles largely by hand in specialized military arsenals. German factories couldn't match automotive industry production rates because they weren't designed for mass production. They were designed for quality and precision, values that served Germany well when building small numbers of superior tanks, but proved catastrophic when competing against American industry, building adequate tanks in overwhelming numbers. The strategic calculus was brutal. German Panthers and Tigers were superior to Shermans in direct combat, better armor, more powerful guns, often achieving favorable kill ratios in tank versus tank engagements. But Germany couldn't produce Panthers and Tigers fast enough to replace losses. America could replace destroyed Shermans within days. When a German Panzer battalion lost 20 tanks, it might receive 5 replacements after weeks. When an American tank battalion lost 20 Shermans, 30 replacements arrived within 48 hours. That production asymmetry made German tactical superiority strategically meaningless. You cannot win through favorable exchange ratios when the enemy replaces losses faster than you can inflict them.
When Germany surrendered in May 1945, Detroit Arsenal abruptly ceased tank production. Contracts were canceled. Workers were laid off by thousands. The facility sat largely idle through late 1945 and 1946 as the Army decided its future. The transition wasn't smooth. Over 10,000 workers lost jobs within months. The local economy, which had boomed during wartime, contracted severely. Housing built for war workers sat empty. Businesses that had served Arsenal employees closed. But the Korean War, 1950 to 53, revived tank production. Detroit Arsenal resumed operations, building M47 Patton tanks, 3,443 produced between 1952 and 1954. The facility continued producing M48 Pattons through the 1950s and M60s through the 1960s and 70s. During the 1973 Arab-Israeli War, the arsenal ramped up to 5 tanks daily, responding to emergency Israeli requests for replacement vehicles. In 1979, it began producing components for M1 Abrams tanks, eventually performing final assembly. In 1982, Chrysler sold its defense division, including Detroit Arsenal, to General Dynamics Land Systems, which continued M1 production until 1987. The facility finally closed in 1996, after 55 years of operation. The U.S. Army retained portions for administrative use, but the massive production floors that once built 907 tanks monthly fell silent permanently. Some Arsenal land was transferred to Warren, Michigan for redevelopment.
The once vast factory complex, symbol of American industrial might, was largely demolished. Small sections remain, repurposed for various light industrial uses, but the tank assembly lines are gone forever.
The Detroit tank arsenal story demonstrates principles that extend far beyond World War II tank production. Lesson 1. Transferable expertise. Chrysler's automotive manufacturing expertise translated directly to tank production. Engines, transmissions, assembly lines, quality control, workforce training, all these skills applied to military equipment. The lesson? Industrial capacity is fungible. Manufacturing excellence in one domain enables excellence in adjacent domains. Lesson 2. Mass production beats craft. German tanks were arguably better engineered than Shermans, but German craft methods couldn't compete with American mass production. In total war, quantity has a quality all its own. Better to field adequate equipment in overwhelming numbers than superior equipment in insufficient quantities. Lesson 3. Speed matters. 7 months from farmland to first tank demonstrated that industrial mobilization can occur faster than conventional wisdom suggests. When national survival demands rapid production, traditional limitations dissolve. The impossible becomes merely difficult. Lesson 4. Workforce diversity works. Women and minorities proved they could build tanks as well as anyone. The social changes forced by wartime necessity, women in industrial jobs, integrated workforces, demonstrated that arbitrary barriers to workforce participation were economically and strategically counterproductive. Lesson 5. Industrial capacity is a strategic weapon. The arsenal's existence deterred potential enemies and reassured allies. After 1942, any nation considering war with America had to account for industrial capacity that could produce 900 tanks monthly from a single facility. That capacity was as powerful a deterrent as any weapon system.
German generals who laughed at car makers building tanks in 1940 weren't laughing by 1943. By then, Detroit Arsenal alone was outproducing Germany's entire tank industry. The skepticism was understandable. Tanks weren't cars. Military equipment required precision, durability, and capabilities that civilian products didn't need. Traditional military arsenals employed skilled workers who understood weapons manufacture through years of experience. But the skeptics misunderstood what automotive manufacturers brought to tank production. It wasn't car-building expertise directly applied to tanks. It was mass production methodology, the systematic organization of complex assembly into sequential, repeatable steps performed by trained workers using specialized tooling. K.T. Keller understood this in August 1940 when he looked at M3 blueprints and asked, "Where can I see one?" He didn't see an impossible challenge. He saw an assembly problem amenable to solutions Chrysler had perfected, building thousands of cars daily. The 7-month construction of Detroit Arsenal, the first M3 delivered while the building was still incomplete, the transition from M3 to M4 without production interruption, the record 907 tanks in December 1942, all these achievements validated Keller's assessment. Chrysler built 25,082 tanks from 1941 to 1945. The car makers, who supposedly couldn't understand armored warfare, produced 28% of America's entire tank output and directly contributed to Allied victory through overwhelming materiel superiority. The German generals stopped laughing. By 1943, they were desperately trying to understand how America produced weapons in such quantities. By 1944, they understood but could do nothing about it. By 1945, they surrendered, partly because American industrial capacity had made continued resistance pointless. The Detroit tank arsenal, converted from farmland to tank factory in 7 months by automotive executives who had never built a tank, proved that industrial capacity, properly organized and motivated, can achieve production that seems impossible until someone actually does it. 25,000 tanks, built by car makers, who never stopped laughing at the German generals who thought they couldn't do it.
In memory of the 10,000 workers at Detroit Tank Arsenal who proved that car makers could build tanks, and build them better, faster, and in greater numbers than anyone thought possible.